Okay, this is January 2022, it's P1 paper, question 5. One quick look at it sees that it's a Radians question. Examiners are often quite imaginative with the sorts of questions that they have with these sorts of things, various different flower beds and gardens and goodness knows whatever. Let's get started straight on with it. A quick hint always will be any information they give you, put it on the diagram. So straight line, radius is equal to 3 first of all. So if the radius is equal to 3, then I've got that's 3 there, and that's 3 there. Tells me that's the centre and the diameter and everything else like that. Straight line BD is parallel to AE, okay. And angle BOA, where's BOA? Right, let's draw that one on there. BOA means that is 0.7 radians, they tell me. And then they say, show that to 4 significant figures, angle BOD, so BOD is going to be this angle here. That's the one that I'm looking for. And as I said, the benefit of doing it on the diagram is that straight away we see they must be the same as each other because we've got congruent triangles here. Of course, if that's 3, then those 2 new lines I've drawn in are 3 as well. You can redraw your diagram out if you want to. Just in terms of time, I've put it on there, but you could draw it out below and put that information on if you want. So part A, another big hint, always just look and see how many marks these questions are worth. Part A must be really quick. It's only one mark question. And hopefully you can see that angle BOD is just going to be pi, 180 degrees for some of you, but pi minus the 2 lots of 0.7. Try and keep everything in radians as much as possible. I know it's tempting to use degrees and keep jumping backwards and forwards, but you really want to try and master actually working in radians, knowing that pi is 180, pi over 2 is 90, even down to things like pi over 4 is 45, and pi over 3 and pi over 6 are 60 and 30. Go away and learn them. It's just worth it. It's going to save you some time in the long run during the exams. Part B, find the area of the flower beds. So what I want to do here, first of all, work out what the flower bed is, but then make it really clear. If I'm doing 2 different sections, which I am, I'm going to do the area of the sector OBD first of all, and then I'm going to take away the area of the triangle OBD in order to end up with the flower bed. Now I can show you that here on the diagram. I can say, if I want that bit there, what I'm going to do is work out all of it and then take away that bit there. But I'm not doing a video for the examiner, so just make it really clear where everything is coming from. And it takes you an extra 1 or 2 seconds to say area of triangle OBD So OBD, yeah, we've got everything that we need here. And if necessary, if you want to put 1.742 on here now, whoops, 1.742, just for when you're trying to work things out, that you can see, have I got all the information needed? Absolutely, I have. If I'm working out the area of a triangle, it's half r squared sine theta. Make sure you've got your calculator in radians. So it's a half 0.7 squared sine 1.742. And then whatever that works out to be, we want it to 1 decimal place. So I'm just going to put 4.43 here, and then I'll work out the 1 decimal place in a minute. Work out the area of the sector as well. So you've got a choice. A lot of you may have worked out the area of the sector first here. So it's free choice as to which way you're doing it, but by just putting a little label on, it's making it clear what I'm doing. Area of a sector is just half r squared theta. So what's that going to give us? It's going to give us half 0.7 squared times 1.742. If I plug all that, that all works out to be 7.83 meters squared. Again, I've just done two of them to 2 decimal places, but the area of the flower bed equals 7.83 minus 4.43. Let's make that look like an equals. Works out to be 3.4 meters squared. Okay, not too bad. And that's a standard one. You should always be able to work out, you should have done lots of those in your revision and in your exercises of working out that exact scenario. Part C then says find the perimeter of the flower bed. So the perimeter of the flower bed, again, it's going to be that length there, that line there, BD, plus the arc BD. So 2 classic parts. The arc is going to be L equals R theta, and the line is just going to be the cosine rule, isn't it? So pretty straightforward, this question. Again, really focusing more on the way that I'm laying my work out than anything else. So if I want arc BD, L equals R theta, so L is just equal to 3 times our 1.742. So that works out to be 5, let's just go back how many decimal places? 1 decimal place again, so I'm just going to do 5.23 meters here. And then line BD, I'm going to be using the cosine rule. So A squared equals B squared plus C squared minus 2BC cos A. A little bit of a reminder of all our GCSE stuff. So BD squared is going to be equal to, well, it's 3 squared and 3 squared and 2 lots of 3 and 3 and cos 1.742. Sorry, 1.742. And I'm not going to do any working out for that. That's IGCSE stuff. That works out to be 4.59 meters if you do it properly. Don't forget to square root. Okay, if you did get an answer of 17 point something, we do things like having a quick check. That length there is going to be a little bit longer than that length there, but it's not going to be 17 compared to 4, is it? And again, when we're looking at the other ones, are being 3s for the radius. If you did forget that square root, you should always be catching yourself doing that. So the perimeter is going to be equal to those 2 lengths added together. So 4.59 plus 5.23, and that works out to be 1 decimal place, they said this time, 9.8 meters. I always go back and have a quick check and just make sure, actually, that you have got all those things done. Oh, did I do it to 1 decimal place? Yeah. Just to make sure that you've got all those done properly, because you don't want to lose any silly marks or something like that on what should be a fairly straightforward question. Hopefully that makes sense.